Welcome back, math students. In this video, we are going to analyze the graph of a function. So this might be the first time that you have dealt with graphs and how it translates to function notation and working within function notation to evaluate or to analyze a graph. So the first question is, what are f of 0, f of 3 pi over 2, and f of 3 pi? So I'm using this trigonometric function. This is the cosine curve, which you don't really necessarily need to know for this, but I thought it's worthwhile because you can see that it's maybe a slightly different curve or function than you're used to dealing with. All right, f of 0. Here's what this means. F of 0 is actually your output. It's saying really your y. So what is y for the corresponding x value of 0? So what we do is we go to our x-axis, we go to 0, and we go up and down till we hit the point on the curve, which in this case is right here on the y-axis. So in this case, y is going to be 4, which means f of 0 is equal to 4. Next, we will go to 3 pi over 2. So 3 pi over 2 on the x-axis is right here, which it happens to be an x-intercept, which means the output is 0. So y is 0, which means that f of 3 pi over 2 is equal to 0. Next, we go to 3 pi. So 3 pi is right here, and we go up or down till we hit the curve. So it happens to be down, and we hit the curve right here, which happens to be at -4. So the output y value is -4, which means f of 3 pi is equal to -4. All right, so next, what is the domain of f? What is the domain of this function f? So if we look at the graph, we can determine the domain. So we can determine domain based on the function, but in this case, we're not really given the function. Or we could determine the domain based on the graph. So we know that the very first x value happens to occur at 0 right here, and the very last x value happens to occur at 7 pi over 2, which is right here. Remember, we're not really as concerned with the y values, where it goes on the y-axis, but we are concerned about the x values. And it's continuous through those values, so therefore it doesn't ever stop, and that means that we have one interval, and the interval happens to be from 0 to 7 pi over 2. And since it is continuous and including those values, we do put brackets. Now, range would be looking at the y values. So here's, I'm going to go to the y values and say, okay, what is the lowest y value that we occur on in our graph? And that happens to be at -4 a couple times. We have -4 here and here, so -4 is the lowest value. And it is continuous, so it goes up through and including +4, but it doesn't go beyond +4. So we have +4 at 3 different locations. And so our range will be, again, an interval notation from -4 to 4, and again, including those two values. And next, we're going to find the intercepts. And notice it doesn't specify what type of intercept, so we will find the x and y intercepts. The first y-intercept occurs at, or the only y-intercept, I should say, occurs here at 4. Then we have x-intercepts at pi over 2, at 3 pi over 2, 5 pi over 2, and 7 pi over 2. And those are the only intercepts. So if we're listing them, we are going to put them in ordered pairs. So 0, 4. Then we have pi over 2, 0. 3 pi over 2, 0. And 5 pi over 2, 0. And finally, we have 7 pi over 2, 0. And those are all of your intercepts. All right, so next we're asked to find how many times does the line y equals 2 intersect the graph. So what I would argue that you could probably do here is create the line y equals 2. So y equals 2 is a horizontal line, and it is going through the y value of 2. So pretend that is a straight horizontal line. And so let's check to see how many times this intersects our graph. So 1, 2, 3, 4. So it intersects 4 times. Number 6, for what values of x does f of x equal -4? So now we're being asked to find the inputs that correspond to the output of positive, or -4 rather. All right, so we're looking for outputs of -4. All right, so I happen to have an output of -4 here and here, and so it says for what values of x does f of x equal -4. Again, f of x, if it's equal to -4, that means what is when y is equal to -4. So we're talking about outputs, and so x in this case is equal to pi and also 3 pi. All right, finally it says for what values of x is f of x greater than 0? So in this case, what we're really asking is where is it above the x-axis? All right, so if you're looking at the curve, we need to look at the curve and where is it above the x-axis. So it's above the x-axis in this interval right here, and it's above the x-axis here. All right, so it's above the x-axis for all of those cases. It's below the x-axis in every other situation. So it's above the x-axis, and I need to put this in interval notation. From 0, remember, we're looking at what x values. Okay, so it starts at 0 right here, and it goes to pi over 2. Now notice that it is not including pi over 2 because we're asking for where it's greater than 0, not where it's equal to 0. So we do need to put a parenthesis there. All right, we're going to put a comma here, and so we're going to go now, we start at 0 again at 3 pi over 2, and we stop at 5 pi over 2. But again, those two values are on 0, so the outputs are on 0, so we are not going to include those two values, but they do need to represent boundaries, so 3 pi over 2, comma 5 pi over 2, comma, and we have one more interval, scroll down just a little bit to give us a little more room, and it's going to go from 0, oops, not 0, sorry, it's going to go from 7 pi over 2, and not including 7 pi over 2, to 4 pi. Now, because 4 pi is not equal to 0, it is greater than 0, the output is 4, we are going to include 4 pi, just like we included 0 in the original first interval, because the output for 0 is actually 4, which is greater than 0. So these are the three intervals of x values where the output is greater than 0. So we're looking for where the output, y, is greater than 0. In this situation, what I'm giving you is a function and asking you to find some of the same information, but some different information for this function. So no longer do you have the graph to find this information. We will deal with the actual function. So it says find the domain of f. And again, in this situation, when you're asked to find the domain and you're given the function and not the graph, you want to primarily ask yourself, what values of x am I not allowed to have? And the two situations you want to look for are when our denominator will be 0, or when you'll have the square root of a negative number. In this case, we have a denominator, and so we set x plus 2 equal to 0. We solve and we get x is equal to -2. So when x is -2, we get a 0 in our denominator, which means x cannot equal -2 in this case. So our interval is from -infinity to -2, not including -2, union -2, to positive infinity. So it's all values from all real numbers basically, except for -2. Next, it's asking, is the point 1, 1/2 on the graph of f? So in this situation, we have an x value and we have a y value, which by the way is the same as f of x. F of x is the output. It's the same idea behind y. It's just in function notation. So what we will do is substitute our values in. So we have 1/2 for f of x is equal to 1 plus 1 over 1 plus 2. So we have 1/2 equal to 2 over 3. So is this ordered pair on the graph of f? And since 1/2 does not equal 2/3, the answer is no. Now, if x is equal to 2, what is f of x? In this situation, you're going to go ahead and substitute 2 for x and figure out what f of x is equal to. So f of x is equal to, and actually, let me erase that, because instead of putting f of x, you really aren't going to put f of x, you're going to put f of 2, because 2 is your input value for x. So we put f of 2 is equal to 2 plus 1 over 2 plus 2, which is 3/4. So f of 2 is equal to 3/4. Number 4 says if f of x is equal to 2, what is x? So this situation is telling you that f of x is 2, so we know the output here, but we don't know the input x. So x plus 1 over x plus 2, and we go ahead and solve that equation. So to solve this equation, and we do want to clear that denominator, we're going to multiply both sides by x plus 2. And that will cancel out my denominator. This gives me now, and I'm going to go ahead and distribute, by the way, save a little bit of time. We have 2x plus 4 is equal to x plus 1. Now we have a linear equation that I'm pretty confident you know what to do from here. So we have, we're going to subtract x to both sides, so 1x now plus 4 is equal to 1, subtract 4, and we have x is equal to negative 3. So when x is negative 3, our output is positive 2. So finally, it says what are the intercepts of the graph? So this is no different from any other intercept problem. To find intercepts, we will substitute 0 for x and also 0 for y. Or in this case, f of x. Let's start with 0 for x. So in 0 for x means I'm actually finding f of 0. 0 plus 1 over 0 plus 2, which is 1/2. So f of 0 is equal to 1/2. So one of your intercepts, and I'll put this off to the right in blue, is 0, 1/2. All right. Next, we want to find that was our y-intercept, and we now want to find our x-intercept. So our x-intercept, we're going to set the output, which is f of x equal to 0, and we solve for our input, x. Well, I'm going to do the same exact process I did for number 4, and I'm going to multiply by x plus 2. But what happens here is that when you take x plus 2 times 0, you just get 0. So 0 equals x plus 1. Solve that, and you get x is equal to negative 1. So your other output, or your other intercept rather, is negative 1, 0. So you have two intercepts at 0, 1/2 and negative 1, 0.
Strawberry, I love you.